We have finished the first term, alhamdulillah. We are going to explain some lessons in the second term, and try to concentrate with me and don't go away. First, we will go to algebra lesson now. We have the new lesson is matrices. Matrices is an algebraic lesson. Yes. Okay, we have the lesson here. We have algebra lesson called matrices. What is the matrices exactly? The matrix is a mathematical mean, okay, used for expressing data in a fair way, to be easy and rapidly to carry out. Carry out what? Carry out the mathematical operations that are concerned with these data. Okay? We use that in math, science, physics, and particularly in computers and electronics. So, my dear students, we will explain to you some lessons about matrices. You have the unit, complete unit, studying matrices. We have here an introduction of it, and the matrix, as we know, or as we said now, is a mathematical mean. Okay, it's a method, it's a way used for expressing data in a fair way and easy way to rapidly and easy carry out the mathematical operations. Okay, let's move to the second example. We have an illustrating example here to be easier for you to know what is the matrices as it is. Let's concentrate here. Illustrate example. We have an example here. If we have a factory in our country produces 3 kinds of electronic sets. If we have factory produce 3 kinds of electric sets: TV sets, washing machines, and refrigerators. And the factory has 2 branches. The first branch called X, the second branch called Y, and the average weekly production of the factory of these sets is shown in the following table. We have a table here. Look carefully, my dear students. We have a table. We have said about a factory. This factory produces 3 types of sets, of electronic sets. First, TV sets. Second, washing machines sets, and refrigerators sets. And this factory has 2 branches called X and Y. So we have here branch X and branch Y. Branch X and branch Y produces what? Produces these 3 TV sets and washing machine sets and refrigerators sets. What are numbers? TV sets here is 50 for the production of branch X and 74 for branch Y. Washing machines, the branch X produce 40 and branch Y produces 25. Refrigerators, branch X produce 37, branch Y produces 49. And we would like to express this data by easier way, which is the number matrix. We have here a matrix. We have 2 parentheses here, like that. And we will write these numbers as follow. Here 50, 40, and 37. Here 74, 25, and 49. So all these data can written as the following and easy way as a matrix. This matrix, we have elements here in a row, and second row we have also 3 columns here. So these numbers written as this way, and this is the matrix. Okay, let's see the matrix again. The matrices lessons are very easy and enjoyable, and you will enjoy it, and it's easy for understanding. We have the last matrix here: 50, 40, 37, 74, 25, 49. We have how many rows here? What is the row? Row here is this row. This is a row, and this is the second row. Okay, so we have how many rows? Yes, we have 2 rows. And we have also columns. Look carefully at me. We have first column, we have second column, we have third column. So we have 3 columns. Each number is called what? Each number of these, 50, 40, 37, 74, 25, and 49, each number here is called an element. Okay, the order of this matrix is what? We also consider that first we write the number of rows, which is 2, by the number of columns, which is 3. So we say that the order of this matrix is 2 by 3. Why 2? Because we have 2 rows. Why 3? Because we have 3 columns. So the order of this matrix 2 by 3, 2 rows and 3 columns. Okay. Generally, we say that the order of a matrix in general is m by n. What is m? M and n must be belongs to z positive. Z positive means no fraction, no decimal. It's only 2, 1, 2, 3, 4, and so on. Okay, so in general, the order of a matrix equal m by n, such that m is the number of rows, n is the number of columns. Okay, let's move, my dear students, to the next example. Yes. Okay, let's move to another example here. What is the definition of matrix then? Definition. We can define the matrix. Definition of a matrix. What is the matrix? We have already write numbers or elements inside the matrix. So it is tabulating. It is tabulating as a table a set of elements. Okay, put in the form of horizontal rows. Put in the form of horizontal rows and vertical columns. Okay, and are put inside it. What the put numbers inside it? We put elements inside it. Okay, we write it as this shape. we have a row here and another row. We can write third row, okay? And we have columns. We have rows and columns, okay? This rows called M, and this number is M, and the number of columns is N, so its order is M times or by N. M and N belongs to Z positive, okay? Let's move to another thing. We have an exercise here, okay? It's very exercise and very easy, okay? Let's move to an example here. This example say about a leather factory. You know about leather factory produces three kinds of shoes, bags and belts. Okay, let's write the following numbers. This factory is a leather factory. This leather factory produces three kinds of products. We have shoes and bags and also belts, okay? And we have also two branches. The first branch called A, the second branch called B, okay? The first branch produce 140 shoes, 180 bags, and 120 belts. The second branch B produce 110 shoes, 200 bags, and 150 belts. Okay, we can make this as a table here, but we can simplify it as a matrix. Okay, we can write it as a matrix. Don't write shoes, bags, belts, or branch A or B. We just write the matrix, two parentheses as this, and we write the numbers 140, 180, 120, 110, 200, and 150. So I'll ask you, what is the order of this matrix? Yes, we have here two rows, so there is 2 by. We have here 3 columns, so it's 2 by 3. 2 rows and 3 columns. It's the order of this matrix. Okay, so we can use another method to write this matrix. Okay, look carefully here with me. We can write it like that. We have here shoes, bags, and belts. Okay, and we write here branch A and branch B. Branch A produce 140 of shoes, 180 of bags, 120 of belts. Branch B produces 110 shoes, 200 bags, and 150 belts. So it's another method or another way to express this data. We can consider them as a table here. Okay, and we can write them as a matrix here like that. we have write 140, 180, 120, and this side write 110, 200, 150. So here we have written these data by another matrix, but this matrix has how many rows? Has 3 rows by how many columns? 2 columns. So its order now is 3 by 2. The same data, we have written them by 2 methods of matrices. This matrix first here, and this matrix. This matrix has 2 rows and 3 columns, but this one has 3 rows and 2 columns. They are the same data. We will call this data here, this matrix is a transpose of this matrix. Okay? Let's move to another example here to how to express the elements of a matrix. If we have a matrix here and we have a data inside it, these data, if the matrix is capital A here, by the way, we express the whole matrix by capital letters A, capital B, capital C, capital X, capital Y, capital Z, and so on. These matrices, we express them by capital letters. But the elements here, we express them using small letters. Okay? If we have a capital A for this matrix here, then we have elements here. This element here, we can say it small a, 1, 1. Why 1, 1? Here this element lies inside the first row. So we have 1. And it lies also in the first column. So we have other 1. So we write it as A11. And the second element, we called it A12. Why 12? 1 because it lies in the first column. Row number 1 and the column number 2. This element will be A13. This element lies in first row, the row number 1, and third column, the column number 3. Okay, now you can complete with me. We have this element here. We can write it A21. Yes, A21 because we have second row here, the row number 2, and first column here, the column number 1. And this is A22, A23, and if we write here, we will write what? Yes, we will write A31 because it is row number 3 and column number 1. A32 because we have row number 3 and column number 2. A33 because we here in the third row and third column. Okay, generally we use small a, ij. What is I? What's j? Small a expresses the element itself, and I expresses the number of rows. J expresses the number of columns. So we will revise again. Capital letters used only for the matrices itself. Okay, but small letters expresses the elements inside these columns or these matrices. This is A11, A12, A13, A21, A22, A23, A31, A32, A33, and generally we call it Aij. I expresses the number of rows and J expresses the number of columns. Okay, Let's now move to an example here. If we have, okay, let's write the example. If A is a matrix and this matrix written as -2 here, 0, half, 1, 6, -4, and we have B is another matrix, 4, 5, -1, 8. We have C, the third matrix here, 3, -3, √5, -1, 0, -2, 2, 1/4, 9, and we would like to find what? To find the order of each one. The matrix A of order what? Yes, we have 2 rows, so it's 2 by 3 columns, so 3 columns. The order of the first matrix here, which is A, 2 by 3. Okay, matrix B of the order 2 rows and 2 columns, so it's 2 by 2 order. This one, C, let's count 1, 2, 3 rows by 1, 2, 3 columns, so its order is 3 by 3. Okay, and would like to write the following numbers. What is A to 2? Look careful at this. Because it's small a, so it's an element here inside the matrix A. A to 2 means the element that in the second row and second column. Second row and second column is this number. Second row, second column in this number, so it's 6. If you want to find out the element B to 1, the element small b to 1 lies in the matrix B. So B to 1 means the element in second row, which is this row, and first column, which is this one, so it's -1. B, we can say C32. C32. We have here small c, okay, so it is an element in the matrix C, and 3 means the row number 3, row number 1, number 2, number 3. Concentrate in the row number 3 and column number 2 here, so the number will be 1/4. Again, we have the row number 3 and column number 2, the intersection number or point 1/4 here. So C32 equals 1/4. Let's practice here another one. If we have C23, what C23? C2 means the second row, 3 means the third column, so it's -2. B to 2. B to 2 lies in the matrix B, the second row and second column, so it's equals 8. Now we will move to another example here. Okay, the question is write by listing here by listing. Number 1, the matrix A, capital A for the matrix, as we know, which is equal A ij, such that I equals 1, 2, and 3, and j equals 1 and 2. We will draw here 2 parentheses like that, and we have the capital letter A for the matrix, and we will write here A11, here A12, and A13. Okay, and I equals 1, 2, 3, so I here the number of rows 1, 2, 3. J expresses the number of columns, so we will have 2 columns. Okay, so we will write A11, A12, A21, A22, A31, A32. Why we cancel that? We have cancelled that because we have 3 rows here and only 2 columns, the first column, the second column. So it will be only this matrix. Okay, we cancel that. So if we have I 1, 2, 3 and j 1, 2, so we write A11, A12, A21, A22, A31, A32. Okay, let's move to another example here. We have many examples, and it will be easier for you because we will deal with numbers. So if we have an example here like that, A equals a matrix, this matrix 4, -1, -5, and 2. And we have another matrix B equals -3, 2, 0, and 1. Okay, and we would like to find out A plus B. A plus B means the adding of 2 matrices. Now they must have the same order to add them. The order of the first matrix here is 2 by 2. The order of the second is 2 by 2 also, so they have the same order. To find out the adding of A plus B here, we write A like that and B like that. A, write it again for -1, -5, and 2, -3, 2, 0, and 1. And we will add the element 4 with the element -3. Concentrate well with me. 4 plus -3 equals 1. And also we will add -1 plus 2. The answer will be 2. We will add -5 with 0, -5. Okay, 2 plus 1 equals 3. Okay, we have added the number and its converse. Okay, so we add 4 plus -3 equals 1, -1 plus 2 equals 1, -5 plus 0 equals -5, 2 plus 1 equals 3. Okay, my dear students, we have a little break and we will return again. Stay with us. Thank you. Lesson for matrices. Now we have some special kind of matrices, so concentrate with me. We have the first type of special matrices here. Okay, let's concentrate here. We have some special matrices. Okay, the first type of matrices is the row matrix. What is the row matrix? Yes, okay, here. There are some special matrices. We have the row matrix. What is the row matrix? The row matrix here is only a row with any number of columns. We can say 2, 1, 0. It's a row matrix. Why it is row matrix? Because it's just one row and any number of columns. So this matrix of order 1 by 3 as example. Number 2, we have also the second special matrices, which is the column matrix. What is the column matrix? It's just a column here. You can say 3, -9, 2. So it's just a row, a column, and any number of rows. So we call it a column matrix. This column matrix is of order 3 rows here, but 1 column. Okay. Another some properties of matrices. Okay. Number 3, square matrix. Square matrix, as its name, as the square. If I have a matrix like that, so the number of rows here will be the number of columns. Say 2, 1, -3, 0, -5, 9, 2, 8, 15. So it's a square matrix. Why it is a square matrix? Because number of rows equals the number of columns. So it's a 3 by 3 order. We have also another matrix or another square matrix like that. We can say 0, 5, 2, 9. It's 2 by 2 matrix. Why 2 by 2? Because we have only 2 rows and 2 columns. Okay. We have also number 4, transpose of a matrix. What is matrix and this transpose here? A is a matrix equals 2, 3, 1, 5, 8, 9. So it is a matrix of 2 by 3 order. We call AT or A transpose of this matrix when we put its rows as a column or its column as a rows. So this first column here, 2 and 5, we write it as a row, and this second column we write it as second row. This third column we write it the third row. Okay, or we can say 2, 3, 1, 2, 3, 1. 2, 3, 1 is the first row, become first column. 5, 8, 9, first row, it becomes second. This second row equals second column. So it will be converged. So it is what? It is transpose of this matrix A. Okay, and we will symbolize it by AT. AT means A transpose. Okay, let's move to another one. Number 5, we call the zero matrix. What is the zero matrix? Zero matrix from its name, of course, will be zeros. All of its elements are zeros, like that. So it's 0 element or 0 matrix, and all of elements equal 0. This 0 matrix, it's of order 2 by 3, because we have 2 rows and 3 columns. So it's 0, 2, 3, and we symbolize it by capital O. Okay, it's null or 0 matrix. Okay, let's move to some questions here. If A equals this matrix -1 and 1 and 4 for the first row, 2, 5, 0, 3, 7, 2, and we have another matrix here like that, 1, 2, 3, another matrix -2, 4 and 0, 0, -1, and -3. We would like to find out 3x plus 2b. Okay, 3a, sorry, plus 2b. Okay, we have here this matrix A, so we'll find 3a by multiplying each element of A by 3. 3 multiplied by -1 equal -3. 3 multiplied by 1 equals 3. 3 multiplied by 4 equals 12. 3 times 2 equals 6. And 15, 0. 3 by 3, 9. 21 and 6. So it's 3a now. And 2b, we will multiply each element of b by 2. So 2 times 1 equals 2. 2 times 2 equals 4. 2 times 3 equals 6. -4. 8. 0. 0. -2. -6. We multiplied each number of this element by 2 because it's 2b. Now we would like to find out 3a plus 2b. Here we will find out the answer, each element added with its corresponding. So -3 plus 2 equals -1. 3 plus 4 equals 7. 12 plus 6 equals 18. 6 plus -4 equals 2. 15 plus 8 equals 23. 0 plus 0 equals 0. 9 plus 0 equals 9. Okay. 21 plus -2 equals 19. 6 plus -6 equals 0. So the final answer is this one, or this matrix. We have added each element with its corresponding element. It's very easy for you. Okay. The equality of a matrix. Equality of a matrix is very enjoyable and easy part. If we have two equal matrices like that, we have A, a matrix, okay, and B is another matrix. This matrix is 2, 1, 5, 3, 0, 9. This matrix also will be 2, 5 over 5, which is 1, 5, 0 over 7 here, 6 over 2, and 9. Are A equals B? Is A equals B? Of course A equals B, because each element here equal its corresponding here. A here equal A11 equals 2, and B11 equal 2 also. A12 equals 1. 5 divided 5 equals 1 also. 5 equals 5, of course. 3 equals 6 over 2. 0 equals 0 over 7. 9 equals 9. So the matrix A equals matrix B. Yes, you say that it's very easy. Okay, we can use this equality to find some symbols or some values or variables. If we have here two matrices are equal, and we have x, 2, 5, and y, and this is 3, 2, 5, and x plus 3, to find x and y. Okay, let's use the property that if the matrix A equal matrix B, then we have the first element equal the first element here. So of course x equals 3, and also y equals x plus 3. So we can say y equals x equals 3. So we substitute by 3 plus 3 equals 6. So x now equals 3 to be equal 3, and y equals 6 to be equal 3 plus 3 equal 6. Okay, let's move to another example. I'll ask you, is this matrix here, is it equal this matrix 2, 8, 9, 6? Are they equal? No, they are not, because 2 equal 2, okay, but 0 doesn't equal 8. Okay, and if we have two matrices like that, 1, 1, 1, and also, and this matrix equal 1, 1, 1, they have only ones. But is this matrix equal this one? Of course not, because here we have number of rows, two number of rows, but here we have just one number of row. Okay, let's move to another example. Find the value of x, y, and z. We have here two columns are equal. This column, this matrix z, 0, 2, 4, 7, and 5. This one equal negative 1, 0, x plus 5, 4, 2y minus 3, and 5. Look carefully as this. We have z is the first element here equals negative 1. So z is very easy for us to find out that z equals negative 1. And x plus 5 equals 2. And we can easily transfer 5 to be 2 minus 5. So x equals negative 3. We have z equals negative 1 and x equals negative 3. If we look at this element here, which is 2y minus 3, this element of course equals 7, the corresponding element for it. So 2y equals 10, 2y equals 10, and so y equals 10 divided by 2 equals 5. So z here equals negative 1, x equals negative 3, and y equals 5. Okay, let's move to another example for you. What is the operations? We will study some operations on matrices like adding, subtracting, then multiplying. And let's move first to the operation adding. Adding matrices. If we have matrix A like that, 2, 1, 3, negative 2. Another matrix B, 5, 2, 2, and 3. And we would like to find out A plus B. A plus B means adding the two matrices. Okay, put these matrices like that, 2, 1, 3, negative 2, 5, 2, 2, and 3. We notice that the two matrices here have the same order. It's 2 by 2 here. It's order 2 by 2. And this one is order is 2 by 2 also, because we have 2 rows and 2 columns, 2 rows and 2 columns. So we can add 2 with 5 will be 7. 1 with 2 will be 3. 3 plus 2 equals 5. Negative 2 plus 3 equals 1. So the result equals this matrix. So it's an addition operation is very easy. It's the easiest thing in this part. What's the scalar multiplying? Scalar multiplying means, my dear students, that a number multiplied by a matrix. Let's see if we have a matrix here like that. This matrix 3, 2, 1, 5, 0, negative 3. And we would like to find out 2A. 2A means 2 multiplied this matrix A. 3, 2, 1, 5, 0, negative 3. We will multiply each element here by all these elements. 2 multiplied 2 equals 6. 2 multiplied 2 equals 4. 2 multiplied 1 equals 2. 2 times 5 equals 10. 2 times 0 equals 0. 2 times negative 3 equals negative 6. So the resulted one here equals 2A. Okay. We have also some examples. If we have A here equals 1, negative 2, 3, 5, 4, and 2, and we have another matrix B like that, negative 1, negative 2, 5, 1, 3, and 2. And we have the third matrix here like that, 2, 0, negative 1, 3, 4, and 6. And we'd like to find out number 1, 2A plus C transpose. Okay. The new thing is transpose here. 2A means we multiply A by 2. Directly we can do it. It's very easy. 2 times 1 equals 2. 2 times 1 equals 2. 2 times negative 2 equals negative 4. 2 times 3 equals 6. 2 times 5 equals 10. 2 times 4 equals 8. 2 times 2 equals 4. Plus what? Plus C transpose. What is C transpose here? We have C here. This is the row, second row, 1, 2, 3 columns. We will transfer the row as a column. 2, 0, negative 1 is the first row, will be the first column. 2, 0, negative 1, 2, 0, negative 1, 3, 4, 6 will be 3, 4, 6 like that. So we find out the transpose of the matrix C, making the rows as the columns, or vice versa. We can say the first column as the first row, 2 and 3, 2 and 3, 0 and 4, 0 and 4, negative 1 and 6, negative 1 and 6. Okay. Now we can add them because they have the same order. We have here 3 rows, 2 columns, 3 rows, 2 columns. We can add 2 plus 2, the first element with the first element equals 4. Negative 4 plus 3 equals negative 1. 6 plus 0 equals 6. 10 plus 4 equals 14. And we have also the final row. 8 plus negative 1 equals 7. 4 plus 6 equals 10. Okay. So we have the final answer for this expression. 2a, 2 multiplied the matrix A plus C transpose, which making the transpose of C. And we add them. This is the final answer. Okay. Let's move to the properties of addition and subtraction for matrices. Matrices as integer numbers, natural numbers. Okay. So we have some properties here of addition. Properties of addition of the matrices. Okay. This is N. Okay. It's commutative. What is the meaning of commutative? Matrix A matrix. Is it equal? Is it equal the plus A? That's right. So A plus B equal B plus A. Examples. The second property is associative. The meaning of associative. If we have added with the matrix B, added with the matrix C, and first the matrix A added with the matrix B in the same bracket, and then we add to them the matrix C, is it equal, okay, plus B plus C? Yes, it's right, because associative is correct for the matrices. Okay, my dear students, it's a pleasure to meet you today. Just the beginning, we have the first episode of this year term. We will meet the next Friday. Goodbye and good luck.